Hi. Okay, great, the mic works. Okay, so I'm Anna. I've put my Twitter handle on there. I also tweeted a link to the slides if you want to follow along there on your own laptop or something. But there aren't actually going to be all that many slides because I'm mostly going to be live coding. And I'm actually going to be re-implementing set timeout for Node.js, like actually dive into Node.js internals and show you how you could implement something like set timeout for Node.js if it wasn't already there. So, as I said, I'm Anna. I have been contributing for a while to Node.js now. I'm close to my 4-year anniversary. And so at this point, I'm actually working full-time on Node.js. I work at a company called Nearform, which is a Node.js consultancy. And yeah, so I've been, so the thing, like if anybody knows me for something, it's workers. Like I basically drove the effort of putting workers into Node.js, not all by myself, but well, people know me for that. I also did a lot of work in HTTP2. I did a lot of work putting broadly support into Node.js. Other things, currently I'm working, working in this Nearform research department means I'm getting to work on cool next generation features for Node.js. Currently that's Quick or HTTP3, which will hopefully support in Node.js at some point in the near future. And yeah, so when I got started doing work on Node.js itself, like that was, it was a bit daunting to me. Like there was so much about Node.js that I didn't know, or like how it worked internally and how to make changes to it. And I want to show you all a bit about like how do I actually build a feature for Node.js. And actually my first commit to Node.js is also related to this set timeout function. So if you ran this code in Node.js a while ago, so like December 2015, that was Node 4. If you run this in Node 4, and this is obviously not the right code because the first argument is supposed to be the function and not the third. And don't ask me why I did this. Like I think I was refactoring some code to use promises and wrote my own custom promisified version of set timeout, and well, it didn't quite work. And so I got this as the response when you run this on Node 4. And it's completely useless. Because as you can see, the stack here that tells you that this number 1000 is not a function. It only shows that something related to timers happened. Like it's waiting, and it's actually waiting this 1000 milliseconds before it shows you this error. So I thought to myself, okay, so either I can debug my own program and figure out where I did something wrong and get the stack trace for that, or I could patch Node.js and basically add a type check to set timeout that makes sure that the function argument is actually a function, because it doesn't make sense to pass anything else. And I mean, there were documentation and test changes, but basically this is the gist of what my first contribution to Node.js was. I added throwing a type error when the callback is not a callback. And I'm not sure if that actually saved me time, because compiling Node back then, it took half an hour, and now it's even longer. But I decided, hey, so I did this, I might as well open a PR against Node.js with it. And so I did that, and well, then I had a working copy of Node.js master on my machine, and I kind of decided to just use that as my default Node.js app, which is, well, I wouldn't recommend it for production use, right? But yeah, so that's kind of what got me into Node.js, into Node Core, working on that. But yeah, so if we want to implement a timeout, like a lot of you might think that setTimeout is just something that is there in JavaScript. Well, when you actually go to the JavaScript spec and you search for setTimeout, all you get is some stuff related to module or regex, which are decidedly not related to timers. And so it turns out this setTimeout thing, it's not part of the language. And even though browsers and Node.js support it, that means it's supported basically everywhere. Yeah, it's just not part of the language. And if you think about it for a bit, that actually makes sense. So like, let's take a look at this code example. We tried connecting to some server, and we set a setTimeout at the same time. Both of these are asynchronous operations. And what the event loop does in this scenario is, so it has to keep both of these things in mind. If the connect thing finishes first, so for example, after 400 milliseconds or something, the event loop has to know that there's still 600 milliseconds to wait until it calls the setTimeout callback. Or the other way around, it has to wait for the network connection to finish or for 1 second to pass, whichever happens first. So it can't actually be part of the language because setTimeout is integrated into the event loop. In Node.js, the event loop is managed by a library called libuv. So that manages that. And like the JavaScript spec doesn't have any idea of how event loops look like. Anything that is part of the language itself is not concerned with event loops. Not even things like promises, because you might think, okay, so promises are async operations too. But all that the spec does is say, well, basically, the whatever executes JavaScript has to know how to run promises and when to run them. Okay. So for this talk, we're actually going to be coding a bit of C++, and I'll try to make that as JavaScripty as possible, but yeah, it's still going to be a bit of C++, partly because so Node.js is written partially in C++, partially in JavaScript, and the C++ part just kind of have to be there because libuv is written in C, V8, the JavaScript engine that we use is written in C++, so we kind of don't have a choice there. Yeah, so one of the central concepts in libuv is, or two of them actually, are handles and requests. You can think of handles as kind of like event emitters, like for example, a socket that from time to time emits like data events when it receives data, or I don't know, file system watchers that emit information when a file has changed, something like that. And the other thing, this request thing, you can think of that as an asynchronous function call. So it's something that is called once, and it has exactly one result, like connecting the network socket, reading something from the file system, scheduling some asynchronous work for example, for zlib compression, we use that. And so you might think, okay, so timers, that kind of works like a request. I schedule a timer to run in a given number of milliseconds, and then it does that, but it doesn't. And the actual reason for this is that there's also set interval in JavaScript, which repeatedly runs the timer, and libuv uses the same interface to implement both of those. So it provides timers as a handle that can emit the callback more than once. In our case, we're just going to be interested in implementing setTimeout. So yeah. Okay. So if we want to implement setTimeout, it makes sense to start thinking about, so what is the data that we actually need to store for a timer? We need to store the function that was passed to setTimeout from the user. So that is a JavaScript function, so we need a JavaScript object associated with this. We also need something to integrate with the event loop. And libuv provides this C data type, UV_timer_t. And that includes a bunch of information like the timer duration, and the event loop that this is associated with, and a bunch of other stuff. So that, because that is written in C, we need a C++ object. And we need some way to associate C++ and JavaScript objects together. One thing that is kind of optional, but that we do a lot inside of Node.js is implementing async tracking. So the idea is that you can actually see when an async operation was started, what happened around that time, and when that async operation finished or called its callback or whatever. And our Node internals are written in a way that makes this kind of async tracking very easy. So we have a lot of utilities to implement all of these things. I'm going to show you a few of these utilities. And these are actually C++ classes, but I think at a JavaScript conference, it might be helpful to just show them in JavaScript. So at the very top of our class hierarchy, a lot of our classes inherit from this thing called memory retainer. And this memory retainer is something that we use in inspector heap dumps, like Chrome DevTools. If you've ever used the Chrome DevTools heap dump feature, you'll see that you can I'll show you later, but you can pretty easily use that to track, figure out where is your memory being used. And this memory tracker class, this helps us inform the inspector or the Chrome DevTools how our internal C++ classes refer to each other or use memory. Yeah, I'll show an example later. So then one step below that in the class hierarchy, there's this thing called base object. And so that is our primary way of associating JavaScript objects and C++ objects with each other. And by using this utility, which it provides a lot of the boilerplate code that we need to have a C++ object whose lifetime is tied to a JavaScript object or the other way around. And this base object thing, it also starts something called the environment, which I'm not going to go into detail about, but you can think of it as a kind of Node.js instance. So for example, every worker in a Node.js application, if you have multiple workers, would be a single environment. And it stores things like the current event loop or the current V8 instance that we use. Mostly so we can look that up more easily. Then another step below in the class hierarchy, we have this thing called async wrap. And this is the internal utility that we use for async tracking. And again, I'm going to show you later in practice how this is actually done. So when an async resource is created, it runs in something called an init hook, which is something that your application can provide. Can basically say, hey, whenever a new async resource is created, please call this init hook and let me know what actually happened. And then it has a second utility, this make callback function. So for one, it runs these other hooks before and after. So when this async resource does something called a callback, it first runs these before hooks so that whatever tracking code you have can know, okay, this happened before that other thing, and similar for the after hook. It also helps us take care of running task queues. So if you call from C++ into JavaScript and you have no other JavaScript running below it, which is the typical case for async operations. So for example, when a file system request finishes and it calls its callback, that happens without any JavaScript running at the same time. It's only the event loop that calls to this. And so what we do in that case is we have to run the next take queue and the microtask queue, so promises, directly afterwards. And so the way that this implemented is, whenever we call into JavaScript, we run the next take queue, and that in turn calls the microtask queue. And So if you're ever confused about the relative timing of things like set timeout or set immediate or process.nextTick or when a promise callback runs, you can keep this in mind that like nextTick and microtasks, these are actually not related to the event loop. These are some things that we implement in Node.js for callbacks into JavaScript, but they always run immediately after we're done calling into JavaScript. So we also have utilities for these two libuv concepts. We have something called a reg-rep. Generally, you may notice that a lot of these classes end in rep, and that is just something that we do internally for some reason. There's no deeper meaning to it. You can just think of it as, okay, this wraps some libuv thing in some way. Reg-rep reps requests. I'm not going to go into detail on that because we're not going to use that. But there's this handle rep thing. And that is what we're going to use to implement our timeout class. And it also comes with some utilities. So for example, these ref, unref, close functions. Close will, well, maybe it's obvious what it does, but it closes the libuv handle. So it actually stops everything that's happening there. And ref and unref, again, I'm going to show you in practice how that's working later. If you've never used these, and there's a chance that you might have never used these. So what unref does is, it tells the event loop, if you're done executing all other stuff on the event loop, don't wait for me to finish. Or I might actually show you a tiny example right now. So this waits 1 second and then, yeah, okay, I started that in the wrong file, but that should not be an issue. So it waits 1 second and then it prints this. And let's say we have this other thing which waits half as long, so it's going to first print the other and then that. And if we call that unref on this, then it's actually not going to wait, the event loop is not going to wait for this operation to finish. These are just helpers that we have and that, and that are supposed to make working with libuv handles easier. And so this is the C++ part that I want to write in a few minutes, except it's written in JavaScript to maybe give you a better idea of what we're going to do. This class has a constructor. It calls the handle rep thing with whatever, with the timer object, with the JavaScript object that we created earlier, or that is created along with it. And we say, okay, for async tracking, this thing is called a timer. We initialize this, which this is a libuv operation, so say, hey, this timer is supposed to run on this event loop. Please do that. We pass a callback to it, which can't really be a callback the same way that JavaScript does it, because libuv is a C library, and callbacks there work kind of differently. We pass it the timeout in milliseconds, so ideally we have made sure at that point that it's a number. We're going to say, so 0 is the repeat parameter. We're going to say, just don't repeat this. And once our callback that we passed it runs, we use this async utility of using make callback, calling the .onTimeout function on the JavaScript object. And actually, this make callback thing, just to be clear, it doesn't make a callback. When I first got started doing Node.js stuff, or working on Node.js add-ons, which also have this function, I got really confused because, like, what does make callback mean here? And it took me a while to get that this is make a call back into JavaScript. It's not make a callback. Okay. So one more thing before we actually get started with the live coding part. Node.js is usually very layered. So we have some things that are implemented in C++ and that use libuv or refer to the event loop in some other way, which in turn talks to the operating system in some way that we don't care about. And we have a JavaScript layer on top of that. So whenever you use a Node.js function, you can be almost sure that that function from the public API is actually implemented in JavaScript. And it might just call out to something written in C++. So there's this internal binding thing. And just so you know, this is kind of like require. It loads a module, with the exception that it only works for modules written in C++ and only in our internal code. So you can't use it in your own application. OK, so let's actually get started doing the live coding thing. So we have this timers.cc file, which seems like a good place for a timers implementation to live. And well, I'm actually going to start by cheating. Because these lists of imports, like C++ doesn't have a module system that is quite as nice as JavaScript's. And so we have these two lists of different imports that we use from other projects. In this case, V8, like being the JavaScript implementation, and these lists of files that are included, which in the case of C++ means, hey, basically copy-paste this file into my own source code. So it's not a real pretty module system. And if I were to do this live on stage, it would be hard, because like figuring out what to include every time you would basically recompile your code and say, hey, we need to include these. And every time you would figure out that you need to include one more. So I announced that we would want to write something like this. And again, this is C++, and I promise it won't all be C++, but unfortunately, there's no way around that for implementing something like set timeout, an actual like Node.js feature that talks to the event loop. I said we're going to have a few parameters, like environment and the JavaScript object that was associated with it. Also, something that JavaScript doesn't have that is actually pretty helpful for us is you can declare private fields that just exist before the constructor runs. In JavaScript, it always waits until the constructor is done, or until it has called super to have a to have access to subfields, if you want to look at it like that. And I think we need to, like I said, this is something that is used for async tracking, and we actually have a list of all the different types. That's not alphabetically ordered this way. OK. And so when you're actually implementing something that uses our async tracking APIs, you can see, OK, these are the things that actually call out from C++ into JavaScript. And you can figure out, OK, so this callback came from this kind of resource. OK. I said we want to initialize this thing with the current event loop, which I think works like, OK, it doesn't. So one thing that I'm going to be doing quite a bit is I'm just going to searching around in the source code of Node.js and look for similar code, as you can see down here. I hope this is large enough for everyone to read, but I think this should work, like the font size. OK, so we initialize the timer. What else do we need? We need this start function, which takes a JavaScript argument, number in milliseconds, and calls these, like, starts the timer in some way. And this is, again, kind of just boilerplate. this is how you define a JavaScript function that is callable from C++. And we'll tell V8 how to make a JavaScript function out of this, but generally this is the signature for that. And it takes an arguments array which we use for getting the arguments that were passed to that function, and also the this value if there is any, and well, also the return value. We actually set that through the arguments. This is kind of just like how V8 made this work. Okay. So we need to get this timeout in milliseconds. This is supposed to be the first argument to this function. Okay, cool. So we have this thing here, a local value. And this is, again, something from the V8 API. And value is just a generic name for, okay, this is a JavaScript thing, whatever. This can be undefined, null, an object, whatever. And local is something that we use to keep track of objects from JavaScript. And so if you're writing C++, if you happen to be used to that, you might be thinking, okay, so why does V8 not simply give us the value directly or a pointer to it or something like that? And the reason that we need these local thingies is that JavaScript works very differently from C++, and in particular, it has garbage collection. And during garbage collection, can move these objects around in memory. And this is something that actually happens when you run your JavaScript application. V8 is just going to keep moving your objects around in memory the way it sees it fit to save memory and to make garbage collection efficient. And well, so this local thing is actually there for the garbage collector to be able to update the value in our own code, in our C++ code. Okay. We also need a way to, so this is going to be called as timer rep.start and then milliseconds. We also need a way to get this value. And this value is, in this case, it's a timer rep instance. And we have some boilerplate utility that does this for us. The way it actually works is this timer rep object that we are going to create later. It has something called an internal field. So a value inside it that is invisible from JavaScript and that contains a pointer to the, like a C++ pointer to the actual C++ object. I think this is the name. Or the other way around, which makes more sense. Okay, I'm going to have to look this up. And we're going to take this from args.this, which we hope is something that has one of these internal fields. Otherwise, this is going to crash, but V8 wouldn't let anybody call the start function with an invalid argument anyway. Okay, what else do we need to do? We need to convert this number to like an actual number that we can use in C++. And so one thing that we do in Node.js is we don't do type checking in C++, or at least usually we don't. And our way to type check in C++ is to actually just say, okay, this is a number, and if it's not a number, let's just crash. So this is what check does. Like if the condition is false, it's just going to crash. And typically the way that we actually implement type checking is to do it in JavaScript in this wrapper function in the public API. So if you ever get access to one of these internal C++ binding functions, it's very easy to make Node.js crash. Okay, if we tell JavaScript, tell V8, okay, I promise this is a number, then it's going to believe us. This is the way to do that, and I'm creating a lot of timeout variables, but and once we have promised V8, okay, this is a number, and if it's not, I'm going to accept the consequences, whatever they are. We can just say, okay, give me the value of this thing. And now we actually need to call UV timer start, like tell it, okay, this is, we're going to start this timer, make it run. By the way, this start function could theoretically also be part of the constructor. It's not, for some reason, it's a pattern that we don't do a lot in Node.js. We have separate functions that correspond to these libuv functions. And it's not going to matter a lot anyway. So I promise there's going to be a callback that we still have to write that. And this is the timeout in milliseconds, and there's no repeat. OK, how does this callback thing look like? It takes the UV timer instance. I think it does. Maybe I'm wrong about that. Again, from this, we need to figure out a way to access the C++ wrapper object, this timer wrap thingy that we have created earlier. And again, we have some boilerplate utility like this thing that we're not going to look into. But that is basically going to give us, OK, so here's this member field of this class, and we can go back to figuring out what the actual instance of timer wrap is. And I don't think we need to do more than call make callback like this set. We don't pass any arguments to that, so 0 arguments, and there's like the list of arguments is null pointer. This on timeout string. So if we look into this file for the environment for a Node.js instance, we can actually see there's a lot of strings defined here. And the reason that we do this is that otherwise, whenever a timer is called, and the other way to do this would be to always create a new timeout string and use that to access the JavaScript property. And that is just unnecessary. We know we're going to reuse this on timeout string a number of times in our application. So we actually have a global table of strings that we can use for accessing strings that we use a lot inside of our application. So you're going to see these are all strings that are probably used somewhere inside Node.js. And if we reuse them, we store them in that table. OK, one more thing that we do need is, so this class has a constructor, but it actually lacks a way to make it accessible from JavaScript. And again, just like the start function, we need a function that we use as the JavaScript constructor for this. For some reason, I'm typing info every time I want to type args. It's like some places we use info, some places we call this thing args, and it doesn't really matter, but I think arguments is just a way better name. Anyway, we have a way to get the current Node.js instance from this arguments thing. How that actually works is none of our business. Important thing is it works. And we can say, OK, please create a new timer wrap thing and associate with the JavaScript object that we were just passed. And again, if you're used to writing C++, you may be thinking, OK, this is a new timer wrap. This creates a new object, and it returns a pointer, and we should delete that at some point. So this line doesn't look like good C++. Turns out that's fine, because when we call this the handle wrap constructor, so I mean, this is kind of like super and so on in JavaScript. When we call the superclass constructor, and remember, so the handle wrap thing is an async wrap thing, is a base object thing, and base object associates the current C++ object with the JavaScript object. So the lifetime of the two are tied together. And whenever we close the handle, we also delete the underlying C++ object. OK, so now we have created the class for timers in C++, and that should actually work. But we still, again, need to tell V8 how to actually use this class. And what I'm going to do for that is I'm going to copy this code because, again, this is mostly boilerplate. This is called from these copied from the stat watcher code. So what that means is, so stat watcher is something that we can use to watch the file system or check fs.stat on some file in a regular interval. But it doesn't matter because it's actually very similar to our timer wrap thingy. This is going to be a lot of just replacing everything. So we say, okay, please v8 create a function that uses timer wrap new as the constructor that has a start method that is called timer wrap. And that is set on this target thing. And target is what we can actually access from JavaScript. And if I didn't screw up, which I probably did, then this should already be compiling. And unfortunately, so like this is not going to start compiling Node.js from scratch. That would be pretty bad because that would fill the entire talk. Compiling v8 alone takes something like 40 minutes or so for me now. And unfortunately, v8 doesn't really get any smaller. So we kind of have to live with that. Okay, cool. So while that is happening, and before it's going to start showing us errors, because I did something wrong. I know that. I always do. But the nice thing about C++ is that it works kind of like TypeScript. It tells you, okay, hey, you did something wrong there. This isn't going to work. Okay, until we get there, I compared one of these implementations that I wrote for practice with the actual set timeout implementation. So cool in this case is our fresh new code that we just wrote, and boring is the old implementation. And you can see that it's more than 10 times faster to use the actual set timeout code in Node. And well, there's some reasons for that. Mostly it's that our set timeout implementation in Node, it's very optimized, and it's not something that you could do like in a 30-minute talk or something. What our actual set timeout implementation does it doesn't create like a libuv timer for every timer that you schedule. There is only one libuv timer, and we manage the rest of the timers in C++ and JavaScript land. So if you schedule 2 timers with a duration of 500 milliseconds, it's just going to call them right after each other. Or if you create a timer with 500 milliseconds and then one with 1,000, it's going to wait for the timer with 500 milliseconds, and it's not going to tell libuv anything about the timer with 1,000 milliseconds. It only does that once it's done reaching the next timer, the 500 millisecond one. So it's grouping timers together. Also, like it's avoiding C++ boundary calls at a number of other things. So if we go back to this slide, to the async utility slides, you see that we run the next queue after we have called this callback. And both of these things happen from C++. So that's at least 2 calls from C++ into JavaScript already. And calls between JavaScript and C++ are kind of heavy. They cost a lot of time. Like, not in the absolute sense. It's still only, I don't know, definitely less than a millisecond, but it adds up. And one of the most common optimizations that we do inside of Node.js is to try and avoid passing data between JavaScript and C++ through function calls. So for example, one thing that we do is we use typed arrays to inform C++ about numbers from JavaScript and the other way around, because writing data into a typed array is actually faster than calling a function that gets these numbers as arguments or something like that. So just so you know, our timeout implementation is much better than what we're writing here, but still. Okay, yeah, it failed. That was expected. Oh, right. Another thing that is nice about JavaScript is we don't have to worry about casting between different object types. If you write TypeScript, you have to care about that. Okay, this is just something that we have to do, kind of. I forgot this here. Anything else? Oh, yeah. These are mostly typos, as you can see, like it's pretty easily fixed. Right, that I actually forgot. So this stat watcher thing, and we're going to copy code from that again. Like I said, we track memory for almost all of our internal C++ classes. And I forgot to do it for this class. We actually have to do it for every single one. Basically, I tell it, okay, this one, it does not reach out to any external memory. And, well, this thing is a macro that tells our memory tracking implementation, hey, so this class has this size. You can figure that out in C++, like actually get the number of bytes that an object of that class has. And this is what we'll report to the tracker. Okay, one more typo. But it's only one error, so it really should work now. Oh yeah, another typo. Okay, I added an S here, so it's called strings, which, you know, it's wrong. Everything else on the list ends with _string, but the reason that I'm not actually fixing this is if I change something in this file, which is used basically everywhere in Node.js, it's going to recompile all of Node.js. If I change something in this file, it's just going to recompile the timers implementation. So I'm just saving a bit of time. Okay. And, well, fingers crossed that this works. It really should, but. So this has recently become one of the more annoying parts about working on Node.js. Like it doesn't stop using more and more time every time we update V8 at least. So I'm going to do some bad things here. I'm going to pass this expose internals flag to Node, which we can use to, well, access internals, which is something that you should obviously not be doing, because if you access Node internals, well, you should at least be prepared for your code to break every time Node.js makes a new release, which is not something that you want to do. But it gives us access to this. To this internal binding function that I mentioned, which lets us access C++ modules. And the timer C++ module, we have this timer wrap class, which we just defined. Okay, let's try to manually make a timer. We've created one. We need to define this onTimeout function. And we're going to start with a 1 second timeout. Yeah. Okay, that's actually okay because I screwed this up the last time I did this too. It's not the end of the world. We actually have to create some objects that, well, this handle scope thing, it interacts with V8. It tells us, hey, this is a scope, or this is a function in which we create JavaScript objects or access them in some way. So you need to make the garbage collector aware that that is happening. And we also need to enter a context. And a context is kind of like well, it's kind of like a global object in JavaScript. And I don't know if you've ever used something like the VM modulars or similar things, but JavaScript engines typically support multiple different global objects and all the things that are associated with it, multiple sets of built-ins. So for example, iframes, I know do that in the browser, and it notes it's this VM module where you can, oh yeah, I named the two the same way. But again, this should really, really work this time. Okay, let's do some of these things again. So, and also, like, you see this warning, right? Like, this is really not something that you're supposed to be doing unless it's for internal testing, and we're developing a Node.js feature, so it's actually okay. We create a new timer, we set this on timeout function, we say do it after 1 second. Okay, now this time it actually works. So let's go into the JavaScript timers code, this is like a regular JavaScript CommonJS module. And we actually, we write a wrapper function for this the way that it would usually be happening. So we actually want to get something that works like set timeout, where you don't have to create the timer manually and everything. I'm basically going to be doing everything that I just did in the REPL. We're going to have to import this timer wrap class. So one thing that we should not forget to do, and I didn't do this in the example in the REPL, we should close this timer, otherwise it's just going to keep lying around as a C++ object, because for libev handles, we need to manage their lifetime manually. We actually have to say, once this is done being closed, delete the object. If I didn't do this, it would, well, it would be a memory leak. It would create new timer wrap instances every time, and it would never actually work. And this time, again, I'm skipping all the type checking because, well, that's not the interesting part here. But so if you actually pass like something that is not a number to this cool set timeout function, it is going to crash. Which is okay, because this is just an example. Also, another thing is, the reason that I'm closing the timer before the function is, it's quite simple. It's, if this function throws, then there's nothing that would close the timer handle. And if there's, for example, in process.uncaught exception handler, it would, like, the application would continue, and this timer.close function would never be called, and that would be pretty bad. Okay, let's call this cool set timeout. Okay. Again, after like say 1,000 seconds. Okay, cool. So we actually wrote set timeout for Node.js. And well, if you're gonna allow me to like go a tiny bit over time, one thing that I announced that I wanted to show is how this interacts with the inspector in Google Chrome. I'm going to call this test.js. We import this cool timeout that we just implemented in Node.js. And again, it's just something that prints hi. It doesn't really matter what the implementation is. Okay, I'm going to set a long timeout for this so that we can actually see this happening in the Chrome DevTools, see this object be alive. The first time I did this, I was really impressed that DevTools actually supported scaling up and down. And we can actually see, okay, we have timer wrap instances created here. I don't think this, yeah, this is, okay. And well, we can see this onTimeout function, and if this onTimeout function referred to some other objects, we could see that in there, and that way we can actually track memory leaks back to where they happen. And we can also see just what kinds of objects are on the heap, what is taking up memory, stuff like that. And another small thing, this async tracking thing, and I'm just going to copy some code here, which is basically boilerplate. It prints out the whatever async thing happens inside this file. So we can see, okay, our init hook here that we passed to this create hook function, it got called, it told us, okay, there's something called a timer. It came from the main event loop. That's what trigger ID 1 means. It's like the C++ object is this timer wrap thingy. It has an ID too, and from that ID we can actually tell, okay, so anything that happens inside here is, well, it comes from this timer originally, and that timer goes away at some point. So, and the reason I changed this to debug instead of console.log is that console.log writes to standard error, and writing to a stream is an async operation. So if I do that, it's just gonna like be a bit more noisy. It's gonna create, it's actually gonna access the process.standard out for the first time, so it's creating that. Also signal wrap, which is just like, forget about that. It creates a next tick object because streams create next tick object, all that stuff. But the important thing is you can actually use this for tracking async operations inside Node.js. So basically we just wrote a fully features set timeout operation, and I was just shown the end slide. So yeah.
Unfortunately, time is over, and we have time for some questions. But if yeah, okay.
Thank you for presentation.
Thank
do
you.
you usually add some unit tests for this functionality?
Yeah, of course. We have a lot of unit tests, and I mean, obviously, I skipped them for this presentation. We also would have to add documentation and everything. Just for fun, I used one of these fake implementations that I wrote for practice, and I set it as the actual set timeout. So I did something like this instead, and then ran the test suite. And like half the timer tests still worked, which is pretty good. But yeah. And our tests are basically just simple Node.js scripts. If they crash, that's an error, and if not, that they work. But yeah.
Yeah, I had a question about the handle scope. So do I understand it right that when we have some JavaScript function down the stack, we don't need to create a new handle scope like in the native callback, because there's already a handle scope that we inherit like from the JavaScript code?
So I'm not sure if I got that question right, but let me just try to explain a bit. So for example, we access this string here inside of the handle scope. And if we didn't do this, and if we didn't have anything that told us not to do this, what would happen is this string would basically be in the garbage collector's memory forever. Because of the way that these local handles here work, where did we have one? Here, for example. There's an implicit handle scope around this whole function. But the way that this works is anything created inside this handle scope stays alive until that handle scope is finished. So like you can create 1 million JavaScript objects and like lose references to them, and they would still be alive because they are referenced by that handle scope. And so that's kind of why they are important. It's not actually so that you can access JavaScript objects. The important part is when is the handle scope done, because that means the garbage collector can forget about all of these handles. Does that answer your question?
Yeah, actually, a question about the implicit handle scope in the start function. Like when we call some C++ function from JavaScript, like do we have the same handle scope that was used for the JavaScript code if you don't create a new one?
Yes, so you mean whether this line is...
Yeah.
Okay, so yeah, whenever we call a C++ function from JavaScript, there's automatically a handle scope around that. So we don't have to care about that inside this function for that reason.